Dear students and my dear friends, today in this session of production and industrial engineering, we are going to discuss some topics from the subject of industrial metrology and statistical quality control, which is an important subject for production and industrial engineering students. The various topics we are going to discuss today are height gauges, depth gauges, filler gauges, etc. And I hope you will understand and enjoy this discussion. So let us start with the today's first topic. So if we talk about the rationales of this subject, that is why this subject is important for production and industrial engineering students, then we can say that diploma holders studying this course are responsible for measures and inspection for ensuring quality of the product on the shop floor. So for this purpose, knowledge and skill about standards of measurement, limits, fits and tolerances, types of inspection and various measuring instruments like height, depth, filler gauges, etc. and SQC, that is statistical quality control, is necessary. So he or she must be aware of quality systems. So hence this subject. Height gauges. So if we define the height gauges, a height gauge is a measuring device used either for determining the height of something or for repetition marking of items to be worked on. The former type of height gauge is often used in doctors' surgeries to find the height of the people. So these measuring tools are used in metalworking or metrology to either set or measure vertical distances. The pointer is sharpened to allow it to act as a scriber and assist in marking out the workpiece. So they may also be used to measure the height of an object by using the underside of the scriber as the datum. The datum may be permanently fixed or the height gauge may have provision to adjust the scale. So this is done by sliding the scale vertically along the body of the height gauge by turning a fine feed screw at the top of the gauge. So then with the scriber set to the same level as the base, the scale can be matched to it. So this adjustment allows different scribers or probes to be used, as well as adjusting for any errors in a damaged or reshaped probe. Types of height gauges. So there are mainly two types of height gauges. Number one is Vernier height gauges. Number two is electronic height gauges. So if we discuss about the Vernier height gauges, the Vernier height gauges has the additional refinement of a Vernier scale for greater accuracy in reading or setting the tool. So here is the basic diagram of a Vernier height gauge. This is, as shown in this diagram, is the main measuring jaw. Here this is the beam of this height gauge, auxiliary head, main scale, fine adjustment screw, Vernier scale, slider, locking devices and the main base of this Vernier height gauge. So if we describe the main base of this Vernier height gauge, the Vernier height gauge consists of fine ground and lapped base to ensure rigidity and stability. The base is made up of robust in construction. Second main part of this height gauge is the beam. So it is a vertical graduated column which is supported on the base. The guiding edge and the face of the beam are perfectly flat. The surface of the beam should have dull finish for the ease of the reading. Third part is the slider. The slider has a good sliding fit along the full length of the beam. It consists of a vernier head carrying the vernier scale and a clamping screw. The fourth main part of this height gauge is measuring jaw and scribers. A measuring jaw and caliper is attached to the front of the vernier head. The upper and lower surfaces of the measuring jaw should be perfectly flat and parallel to the base of the height gauge. So the projections of the scriber beyond the jaw should be 25 mm minimum. So when the scriber is co-planed with the base, the vernier must be at 0 position. The fifth main part of this height gauge is the auxiliary head. So it is attached to the beam above the vernier head. It consists of a suitable fittings to give a fine adjustment of the slider, and clamping screw is also provided so that the slider could be clamped to the beam effectively after the fine adjustments. So when we take or measure the reading of an object, we put here, the object is put here whose height is to be measured. So this is the main measuring jaw of this vernier height gauge. Second is the electronic height gauge. The electronic height gauge has a digital readout that gives the height. So here is the diagram of this vernier height gauge. This is the electronic vernier height gauge. This is the main measuring jaw of this height gauge. The object whose height is to be measured is placed here in front of this jaw. This is the locking screw of this height gauge. This is the digital display where the reading, we can take the readings, on off button. This is the units of reading, inches or in millimeters. This is preset button, and this is hold button. This is zero set button. So vernier scale. If we define a vernier scale is an additional scale which allows a distance or angle measurement to be read more precisely than directly reading a uniformly divided straight or circular measurement scale. It is a sliding secondary scale that is used to indicate where the measurement lies when it is in between two of the marks of the main scale. So verniers are common on the syntax used in navigations, scientific instruments used to conduct experiments, machinist measuring tools, all sports but especially calipers and micrometers used to work metals to find tolerances and used in surveying. When a measurement is taken by mechanical means using one of the above mentioned instruments, the measure is read off a finely marked data scale, the fixed scale in the diagram. So the measure taken will usually be between two of the smallest graduations on this scale. So the indicating scale vernier in this diagram is used to provide an even finder additional level of precision without resolving to eliminations. So here is the diagram of Vernier caliper. We can say this is the A side of this side is used to measure the external diameter of the object. B side, this side is used to measure the external diameter of the object, and C part, this is used to measure the depth of a vessel. This is the main scale, this is the fixed jaw, and this is the movable jaw. This is movable is the vernier scale. So if we talk about the introduction to the least count of the vernier caliper, so to understand the least count of vernier caliper, we must first get the idea of structure of the vernier calipers. So as shown in this figure, vernier caliper is an instrument used to measure the internal and external diameters of small tubes, depth of given vessels, diameter of thick wires, etc. So it has two scales. One is the vernier scale and other is the main scale. The vernier scale is also called the sliding scale as it slides on the main scale, which is fixed. So there are two portions on a vernier caliper on which objects to be measured and kept. One is the portion labeled as A in this diagram. It allows for measurement of internal diameter, and the other portion is labeled as B in this diagram, which is for the measurement of the external diameters. A third part of the vernier caliper, which is used for keeping the objects to be measured, is labeled as C in this diagram. It allows for finding the depth of the vessels. The part labeled B in the diagram is used for measure the external diameters. Here the object whose diameter is to be measured is kept in between a fixed jaw of the vernier caliper and the movable jaw, which is continuous with the vernier scale. So least count of vernier caliper. The least count of vernier calipers is, as the name suggests, the least or the finest measurement you can take with the help of the vernier caliper. So it is measured by dividing the least count of the main scale by the total number of divisions on the vernier scale, which is movable scale. So least count of main scale is, the main scale is calibrated in millimeters. So to get the least count of the main scale, count the number of divisions on the main scale in 1 centimeters of it and divide 1 centimeter into that much number of divisions. The value obtained is the least count of the main scale in centimeters. For example, if there are 10 divisions in 1 centimeters of the main scale, which is fixed scale in vernier, its least count is equal to 1 divided by 10, that is 0.01 centimeters. Second is the number of divisions on vernier scale. Vernier scale is the movable scale in this vernier caliper. In most vernier calipers, the vernier scale has 10 divisions. Count the number of divisions on the vernier scale. Use a magnifying glass if necessary. So least count of vernier calipers. So if we discuss about the numerics of this system, Thus, the least count of vernier caliper is equal to least count of the main scale, which is the fixed scale, divided by the number of divisions on the vernier scale, which is the movable scale in this vernier. So, for most vernier calipers, least count of the main scale is equal to 0.01 centimeters. Number of divisions on vernier scale is equal to 10 divisions. Thus, the least count of vernier caliper is equal to 0.01 divided by 10 centimeters, which comes out to be 0.001 centimeters. Thus, since the least count of the vernier caliper is 0.001 centimeters, it can be said that when measuring with the help of this vernier caliper, you can get an accuracy of 0.001 centimeters. Thus, since vernier caliper can efficiently measures dimensions up to 10 raised to power minus 3 centimeters, they are extensively used to measure the internal and external diameters of tube as well as the dimensions of many more objects. So, this is the diagram of vernier scale. Here, this is the main scale of this vernier caliper. This is the fixed jaw attached to this main scale. This is the vernier scale, which is movable, and this is the movable jaw of this vernier caliper. So, if we discuss about the procedures for taking the observations, so first of all, study the main scale and vernier scale of this vernier caliper, which is to be used. So, calculate the value of one small division of main scale, then count the number of divisions on vernier scale, dividing the value of one division of main scale by number of divisions on vernier scale, and thus the least count is calculated. So, before using the instrument, check the zero error, that is, the zero line on the vernier scale must coincide with the zero of the main scale. Now, adjust the workpiece between two jaws. The excessive pressure should not apply on workpiece while fitting between two jaws. So, now take the reading on the main scale in millimeters and observing the divisions just on the left of the zero of the vernier scale. The number of divisions of vernier scale which exactly coincide with any line of the main scale is counted. The reading is calculated by the formula, that is, total reading comes out to be main scale reading plus the number of coinciding divisions of vernier scale multiplied by least count of the vernier caliper. So, here is an enlarged view of this two vernier scale. First is main scale, which is the fixed scale in vernier caliper, and other is the vernier scale, which is the movable. So, an enlarged view of the above caliper shows it has a resolution or precision of 0.02 mm. The reading is 3.58 mm, as the 3 mm is read off from the upper fixed data scale, that is this just left side from the this 0 of the vernier scale. The 0.58 mm is obtained from the lower sliding, indicating scale at the point of closest alignment between the two scale, this portion. So, the total reading comes out to be 3.58 mm. So here is an example of object being measured, that is how we can take various diameters and various readings of different objects. In first measurement is 5 mm, as the 5 of this fixed scale coincide with the this level in this Vernier scale. So reading comes out to be 5.0 mm. In second case, reading is 5.1 mm, as 5 on this main scale is just left side of this 0 reading of the Vernier scale, and the reading 1 is just matching with this first reading of the fixed scale. So the total reading comes out to be 5.1 mm. Similarly, in this case, total reading comes out to be 5.5 mm, as this 5 comes on just left side of this 0 Vernier scale, and the fifth position of this Vernier scale just coincide with this level of the main scale. So the total reading comes out to be 5.5 mm in this case. The Vernier scale is constructed so that it is spaced at a constant fraction of the fixed main scale. So for a decimal measuring device, each mark on the Vernier would be spaced 9/10 of these on the main scale. So if you put the two scales together with 0 points aligned, then the first mark on the Vernier scale will be 1/10 short of the first main mark. So the second 2/10 short, and so on up to the ninth mark, which would be misaligned by the 9/10. So only when a full 10 marks have been counted would there be an alignment, because the 10th mark would be 10/10, that is a whole main scale unit. So short and will therefore align with the ninth mark on the main scale. So now if you move the Vernier by a small amount, say 1/10 of its fixed main scale, the only pair of marks which comes into alignment will be the first pair, since these were the only ones originally misaligned by 1/10. So if we had moved it 2/10, then the second pair and only the second would be in alignment, since these are the only one which were originally misaligned by that amount. So if we had moved it 5 times, then the fifth pair and only the fifth would be in alignment, and so on for any moment. Only one pair of marks will be in alignment, and that pair will show what is the value of the small displacement. Vernier accuracy. So if we discuss about the Vernier accuracy, that is what is Vernier accuracy, then we can say that Vernier accuracy is the ability of human eye to see clearly. Vernier scale can be read, because the human eye can detect whether two line segments are aligned or if they are slightly off alignment. Vernier accuracy is the ability by a person to detect the proper alignments of two line segments. So in most people, Vernier accuracy is particularly high, allowing one to accurately differentiate between alignment and misaligned mark on a Vernier scale. Precautions taken while using Vernier height gauges. So there are some precautions which are to be taken before using this vernier height gauge. These are all the measurements should be performed on surface plate. So the base of height gauge should be clean and free from dust. Springing of measuring jar should always be avoided. So check the zero error, that is error resulting in the wrong calibration of the instrument. So check the parallax error, that is error due to wrong positioning of the eye, if any. So final setting of the vernier height gauge should be made after the slider has been locked to the column. Height gauges should be tested for straightness, squareness and parallelism of the beam, measuring jars and scriber surfaces. Vernier depth gauge. Vernier depth gauge are used to measure the depth of the holes, cavities and other components features. They are available in various configurations depending on the specific applications. So depth gauge categories include dial depth gauges, digital depth gauges, depth micrometers, thread depth gauges, flush pin gauges, depth rules, combination depth angle gauges and vernier depth gauges. Dial depth gauges displays data in a pointer or needle mounted in a graduated disc dial. The dial indications dimensions and positions around or form a reference point. Examples of depth gauges graduations are 10 0 10, 45 0 45, 4 0 4, 50 0 50, etc. So dial display design options include clockwise and counterclockwise rotations, or we can say anti-clockwise rotations. One on multi-revolutions, calibration and long amplifiers. So with dial depth gauges, the analog amplifier provides a remote electronic equivalent to the mechanical display. So digital depth gauges present metrological data in numeric or alphanumeric form. So they often have data output capabilities that use serial or other formats. Digital readouts are precise digital displays that are integrated into dimensional depth gauges. So depth micrometers are another type of depth gauges with a digital options. Typically, depth micrometers are used for precision dimensional gaugings. They are made of a ground spindle and an anvil that is mounted in a T-shaped frame. Micrometers depth gauges are also available in both scales and dial varieties. Depth gauges include thread depth gauges, flush pin depth gauges, depth rules, combination depth gauges and vernier depth gauges. So thread depth gauges measures the depth of the thread surface in a hole. So these all are used depends on the requirement of the object. So flush pin depth gauges are go no go functional gauges that rapidly assess the depth of the opening. So depth rules allow quick assessment. Typically depth rules are used in application where precision is not a high priority. So combination depth angle gauges indicate the depth of the orientation of a hole. So Vernier depth gauges have graduations engraved or printed into a surface. Surface may be linear or drum. The main scale provides an indication of the gauge dimensions to a standard precision level. For example, tenth. The Vernier scale also allow an increased level of precision, for example,